So, assessing normality is exactly what it sounds like. We're trying to decide if our distribution is normally distributed. So basically, they're going to give you your values, and you're going to have to determine whether the overall distribution is normal or not. Could I use a normal distribution to approximate? So to see if it's approximately normal, there are three different ways you can do this. You can plot the data, so make a graph. So create a histogram or create a stem plot. So some type of graphical display that would show whether it looks fairly symmetric and bell-shaped. So you would basically make a histogram and check, does it appear to have kind of that normal curve to it? Is it symmetric? Is it unimodal? Does it tend to follow that bell curve? If I were to draw a curve to it, does it look like what we expect? So that's one possibility. The second possibility would be to check to see if it follows the 68, 95, 99, 7 rule. We know that every distribution, or every normal distribution, has to follow this rule, which says if I reach one standard deviation in each direction from my mean, I should capture 68% of my observations. If I reach 2 standard deviations in each direction from my mean, I should catch 95% of my observations. And if I reach 3 standard deviations above and below, I should capture 99.7% of my observations. So we would actually check how many values are within 1 standard deviation from the mean. How many values are within 2? How many values are within 3? And when we check those 3 percentages, we would determine whether that's close enough to say that it's normally distributed or not. So that's going to be a second method that you can use. The third method is to use what's called a normal probability plot, or they'll abbreviate it NPP. Now this is one that you would do on your calculator. So if you want to get your calculators out, we are going to do this, show you the process for it. So make a graph. Most often you want to do something with a histogram. That's usually the easiest to kind of take a look at. Check to make sure it follows the 68, 95, 99, 7 rule. Or check the normal probability plot. And we'll show you how to make that here in a little bit. So, here we have data on the unemployment rates in the 50 states. So they went to each of the states, they recorded the unemployment rate, and they just listed it out into a set of data here. Now what I want you guys to do in your calculators, in your lists, so you get your stat enter. So in list 1, if there's already something in list 1, just scroll up, highlight list 1, hit clear. Don't hit delete. Hit clear, and then scroll back down. It's going to clear that list out. I want you to enter these values. So put in all 50 values. I'll give you a couple minutes here.
How often will the distribution be normal?
Just depends on the distribution itself. So there's not really a set like this is how often it should be normal or anything like that. It just depends on how the data lays out.
So there'll be 50 values.
No. No, if this was one, and in fact, most of the time they would probably give you, like instead of giving you the data, they give you like the information. Here's the mean, here's the standard deviation. So you most of the time check like the 69, 5, 9, 7, pretty cool calculation. Now, as you're doing this, be very careful that you're plugging everything in correctly. done, just go ahead and put your calculator down so I know you're finished. Looks like most everyone's done. If you're not quite finished, that's fine. If you don't get every single point here, as long as you're close, you should get an idea of what we're doing. So the main thing I want to focus on is the process, so you guys are able to do this on a normal problem. So once we have our information in, okay, we can create, now you can create a histogram on your calculator. So what you would want to do is, first of all, go into your y equals screen, so like where you would type in an equation, a line or something to graph. So go into your graphing mode or graphing screen, clear out any equations you might have in there now. So get rid of any equations that might be in there that would graph if we were graphing. Okay. So when you want to graph and get a histogram, and so also do box plots, or what we're going to talk about here in a second, a normal probability plot, everything's located in your stat plot menu. And to get to stat plot, you hit second y equals. Now if you have a different calculator, if you have something that's not a TI-84, we might have to do this on a one-to-one conversation later, so just kind of follow along, or you might have to look it up online or something like that. So if you have a TI-84, second y equals. Now you should have options like plot 1, plot 2, plot 3. Everybody should see that, yes? Okay, so you're just going to choose plot 1. So go ahead and hit enter. When you get into that menu, the first thing that's going to be happening is there should be a little cursor blinking on the on. So there's an on or off option. So right now, we want stat plots to be turned on. If you were doing regular graphing, so if you use these for another class and graph, you want to make sure you come back in and turn this off, or it's going to mess with your windows and your settings. Okay? So you're going to turn it on for now, so just hit enter on the on and make sure that that on is highlighted. Okay? And then, right below that, you should have 6 different options for graphs that it can create. So the very first option you see looks to be a dot plot, which is going to actually be a scatter plot. That's going to be something we talk about in the next chapter. Okay, so you have a scatter plot option. You have kind of like a line graph as your second option. Your third option would be a histogram. So if you wanted to just get a quick look at what a histogram would look like, you would highlight that option and hit enter. Now, once you hit enter, a histogram is univariate, one set of data. So you should have an option that says, what list do you want us to put in? So the default is list 1. That's why we always want to put things into list 1 in our calculators. If we needed to choose a different list, then you'd have to go to the list menu and choose a different list depending on where you put yours in. So you want to make sure list 1 is chosen. Frequency, you just leave it 1. And then if you have like the color version of the TI-84, you can choose a color that you want to show up. Okay. Otherwise, all you would do then is hit zoom. So the zoom button is the top middle. And then it's going to be option 9. So zoom stack. So if you hit zoom and then hit the number 9, a histogram should pop up on your screen. Is everybody getting that?
I hit zoom, it brought up 4 tabs, and I hit 9, it does nothing.
Oh, make sure, so go ahead and quit out. If you got that, if it didn't come up with something, go ahead and hit second quit, and go back into second y equals. And then go into the plot 1 again, and then from there, just right away, go ahead and hit zoom, and make sure a new menu comes up, and then hit 9. Okay. So sometimes when you've highlighted that list 1, it gets switched into alpha mode, which gives it a different command than zoom. So that sometimes kind of messes it up. So you just want to be careful with that. So everyone should be seeing a histogram right now on the calculator if you have the 84 and we're following along. Is that correct? Okay. So that would be a quick look at the distribution. Does it appear to be normally distributed and so on? Okay. Now, your calculator then would have selected its own class size, counted up the values that fall into each class, and made the histogram based off of that. Depending on if you made it by hand, yours might look a little something different. So like for instance, if we did it with a different class size, like 4 to 5, 5 to 6, 6 to 7, 7 to 8, and so on, by classes of 1, we get something that looks something like this. Okay? So if we wanted to decide if this was approximately normal, we would evaluate the histogram shape. Does it appear to be fairly symmetric? Yeah, it appears to be pretty symmetric. Does it...
Normal distribution. Can I have Joey for 1 second?
So does it appear to be symmetric? Unimodal. So it appears to be unimodal. The other thing then is, imagine drawing a curve on it. So if we looked at a normal curve, so we'd be starting out in the tail here, we'd be coming up, coming back down, creating our tail to the bottom. Does a curve seem to approximate it fairly well? Okay, and we're not looking for perfect. Obviously a curve's not going to fit boxed lines and things like that, but overall, does it appear to kind of follow that normal look, that bell shape? Okay, so that's basically what you're doing. You're just evaluating based on the picture, does it appear to be fairly normal? And then you'd make your conclusion. Now again, this is one that's kind of a gray area. Some of you might say, yes, this appears to be approximately normal because it follows the curve close enough. Some of you might be a little weirded out by the fact that some of these are a little bit off. Okay, so you might say it doesn't really seem to be that good when approximated by the normal distribution. So you just have to defend your conclusion. You might be a little bit different than someone else depending on what they see. Okay? For that reason, this is not going to be your best option every time. Okay? There's a lot of subjectivity when all you're doing is looking at a picture and deciding for yourself whether you think it's distributed normally or not. So this would probably be the last option I would choose. Okay? So that's how you would do it though. Does everybody follow along the process on the calculator? Or you could create it by hand using the same methods we talked about in Chapter 1 for creating a histogram. Okay? The second option is to check and see if our distribution follows the 68, 95, and 99.7 rule. So that means we need to calculate our mean and our standard deviation. So in your calculators, if you were calculating mean and standard deviation, what's our process for the 84? I already have my list entered, so all I would need to do is the 1-bar stats. So go into stat, over to calculate, get your 1-bar stats. Okay. Now if you did it correctly, you should get a mean of about 8.682, and you should get a standard deviation of 2.225. If you didn't get that, it just means you might have messed up on one of the numbers or missed a number, added a number, something like that. So don't worry about that right now. Just kind of follow along with the example then. Okay? So we should get that mean and that standard deviation. Now, what we would need to check then is we would need to check our cutoffs. One standard deviation above or below means I need to take my mean and add one standard deviation. So I would take 8.682 plus 2.225. That gives me an upper cutoff, 10.9. I would subtract the standard deviation. So 8.682 minus 2.225. That gives me a cutoff, 6.457. So our normal distribution says 68% of our observations should be between 6.457 and 10.907. So what you would need to do then is go back to your list of values, and you would count up how many values are in this range. So in this case, you should have found 36 out of the 50 that fell into this range. So the percentage, 72% of our observations, 72% of our states fell within 1 standard deviation of the mean. Does everybody understand that process? Okay, so that's what we're looking at. Now, if I want to reach 2 standard deviations in each direction, then I need to take my standard deviation and double it. I want to reach 2 of those standard deviations. So I take 8.682 plus twice my standard deviation. Gives me a cutoff of 13.132. Then I need to reach down, so 8.682 minus twice my 2.225. It gives me 4.232. So then when I count up how many states are in between those two values, we find that 48 of the 50 states fell into that range of values. So about 96%. And then for 3 standard deviations, it's the same process. Add 3 times the standard deviation to the mean, subtract 3 times the standard deviation from the mean. There's my new range. And in this case, all 50 states fell within those range of values. So what we would need to do at this point is evaluate. I got 72%. Normally that should be 68. I had 96%, that should be 95. And I had 100%, that should be 99.7. So overall, did we seem to follow the 68, 95, 99.7 rule fairly well? Yeah, the first percentage is a little bit higher, but everything else was pretty close. 96 versus 95 is not much different. 100 versus 99.7, not that much different. So based on our analysis here, we should conclude that it's approximately normally distributed. It does follow that empirical rule fairly closely. You would have to, so you can do this one. If you choose this method, which to me is one of the better ones, because it actually shows each of the percentages, you could go piece by piece. You're going to be calculating one at a time anyway. Now, for instance, if you calculated this first standard deviation and you got like 85%, would you really need to continue on checking 2 and 3 standard deviations? Probably not, because that's a huge discrepancy between 68 and 85. Okay? Or if you got something that was extremely low, you're probably not going to continue. But if you get something that's pretty close to 68 like this, then you would have to proceed to the next to check. Does it also meet the 95? If it's something radically different, then you could stop there. But if it's fairly close, you'd want to continue on. And if you're pretty close through all 3, then you can conclude that it's approximately normal. Is everyone okay with that process? All right, so that's the second method, one of the better methods for sure, because you can actually calculate the values you have and calculate those intervals. Now the third option is to create a normal probability plot. So here's the calculator version again. So if we want to create a normal probability plot, you're going to go back into that stat plot menu. So second y equals, go ahead and choose plot 1. And this is kind of like your lists idea. You always want to replace plot 1 with something else. If you don't and you forget to turn it off, you're going to get 2 conflicting sets of data or graphs trying to coexist on a screen. It's not going to work for you. Okay? So always choose plot 1 and just redo the whole thing. So plot 1 should already be turned on. That shouldn't be an issue. So if you go down to your choices, the normal probability plot is the last possible choice. So you're going to scroll right all the way to the end. So the 6th choice for graphs there. And you're going to hit enter to choose that graph. No, don't hit down. Just hit right. So you're up here. Go right all the way. Okay. Yeah, so even though like on some of your 84s, it's the graphs are stacked, hit right. Because if you hit down, it's going to go to the next menu on the item, or the next item on the menu. Okay? So scroll right all the way to the end. So it looks like kind of like a scatter plot again, or like a dot plot. So it's going to be something like that. So you choose that option. List 1, or whatever list you put your data into, needs to be selected. And so then again, you would hit zoom. Make sure it comes up with that menu of different items. And then the number 9. So everybody should be seeing something that looks similar to this. Everybody getting that graph to pop up all right? Okay. So your goal here, if you're checking a normal probability plot, is simply to determine if it's linear or not. So if we look at this graph, what we're basically trying to decide is, overall, does this appear to be fairly linear in shape? Now, when we talk about these, and we're talking about the linear nature, we don't care about little curves here and there. For instance, we do see a little bit of a curve right off of the bat here. So we're looking here, we see kind of a little bit of curve there. That's not what we mean by a curve. Overall, if I were to look at this, we could fit a line pretty well to this data, right? That's kind of what we're talking about. Ignore little waves that occur here and there. What we're talking about would not be linear, would be something with a big curve. So something that curves all the way in either direction, okay? So anything with a big sweeping curve, we would not consider normal. But otherwise, if it's fairly normal or fairly linear throughout the entire graph, we would say that the distribution is approximately normal. Okay? So, as far as the 3 options are concerned, if you have the data at hand, I would actually choose this one every time. It's way easier, way faster. You don't have to do all 3 calculations for the 1, 2, and 3 standard deviations. All you have to do is input the data, choose the normal probability plot, and say whether it's linear or not. Now, if you choose this option on like a quiz or a test, you need to show me a sketch of your normal probability plot. You need to show me that you did it and got the correct graph. So all you have to do is just draw a couple quick axes and just plot a sketch. It doesn't have to be perfect, but just sketch what you see on your screen, and then make the explanation. The normal probability plot appears to be fairly linear, so our distribution should be approximately normal. Or the normal probability plot is very curved, so we do not think it's approximately normal. Okay? So you have to show me the sketch. If you chose the histogram option, you have to show me your histogram and then your explanation. It looks as if it's fairly normally distributed based on the symmetric unimodal aspect, or it's not because it's skewed, or not because of whatever. And if you choose the 68, 95, 99, 7 rule, you have to show me the first interval, the second interval if that first one passes, and the third interval if that third one or second one passes. So if at any point you run into something that doesn't make sense, you would stop the process and say it's not going to be normally distributed. I found 80% in my first interval. That doesn't make sense for a normal distribution, so you don't have to continue. Is everyone okay with that?
What does that mean? Is it going to have us demonstrate each kind of strategy?
No, most of the time it would be one that you'd either get to select. So it would just say, is this distribution approximately normal? And then you choose. So you either make your own histogram, make your normal probability plot, or check your 68, 95, 99, 7. You would get to choose that option. Now, other times it might force you into one or another. Like if they don't give you the data, but they give you the mean and standard deviation, your only option is to check 68, 95, 99, 7 because you can't get the graphs if you don't have the individual values. Does that make sense? So you have to know how to do the 68, 95, 99, 7 just in case they don't give you the data. But if they do give you that data, I would probably stick with this option every time. Sketch the normal probability plot and say it's linear, so it means it's approximately normal, or it's non-linear, not approximately normal. You okay with that? All right. And that's it.